Chemistry is our life. Let's see and welcome to you today.
Chemistry is very important for you. Let's start our program today and concentrate with us. Let's go.
Temperature of the chemical reaction.
Let's follow another experiment about the effect of temperature on the chemical reaction.
Let's see the first one. The experiment to illustrate the effect of the temperature on the chemical reaction at equilibrium. What happened? Let's see.
Here we have two flasks that contains some kind of gas, and we have one of them in ice that we see here and the other one in the normal temperature.
And you see what happened if you add one of them in ice and a normal one. Let's see. Now the temperature here appear the different for the color from the brown to
what? To colorless.
Complete. What happened if we are in waiting? We see the temperature is changing now. There is no color for the second retort. The first one, it has brown color. Stay. Do you think what is the main factor that affect here?
Here the main factor is the temperature. One of them in the normal temperature as 25 degrees or 27 degrees. But the second one that's found in the ice medium,
we can say the main factor that affect here is the temperature. It's easy, important. Now let's see what happened.
If we bring a flask filled with nitrogen dioxide gas NO2, reddish brown color, and place it in a cooling system, what will happen here?
For the cooling, directly we say mixture, we observe that the intensity of the color decrease gradually. What happened until disappear? Ask yourself, why disappear here?
Here we have some kind of the temperature because we have what? We have the collision between the molecules of the compound that stop to move or what? Or decrease in its collision.
The first, you have here the first beaker, it has ice, temperature here -3. Second one, we have higher about 9 degrees Celsius. Now, do you think what is the difference between the effect of temperature for each one? To know that, we must add the thermometer for normal one for third bottle. What happened?
Here we have the molecules or the collision between molecules of each one. Number one, we have -3 degrees centigrade. It's what? It's the decreasing the reaction, or the reaction will be slowly. And the second one, it will be more faster. And the third one in the normal state, it's what? It is the biggest one or the largest one in the speed.
Now we add lighting stick for each bottle and we see what happened because we want to see the effect of temperature on the molecules. The sticks here, it's lighting 1. When we add it for the different bottles, first, it has ice, it has low temperature. Oh, what happened and what do you see?
Here we have the light in the first one, it's slow one, or it is little amount of light. And the second one, the light will be more glowing. And the third one, it has a temperature of the normal temperature, it is the glowest one. What's happened here in each one of them?
This is back to temperature, which has a collision between the molecules. For the ice, the collision here is slowly. So, directly we say light is slowly, collision is slowly, has low effect. It means low temperature. But second one,
it's more collision between the molecules of water here or the liquid. Why? Because the temperature increased the spaces between the molecules inside this liquid. So the effect of heat energy, it makes what? The reaction more speed. And What happened in the third one?
Third one, it's brightness. It means the light increase. This it means when the light increase, temperature increase. This means that. It means the collision between the molecules increase. How can I know? By the different light for each bottle. It's good to understand this. What about to get the other one?
So we have here when the flask containing the gas removed from this cooling mixture and kept at the room temperature about 25 degrees centigrade.
Sure, we know that. Yes, it's 25. Do you think that?
Yes.
What else for the other?
We found that the reddish brown color starts to appear gradually in the gas in the first experiment. So the and increase when placed in the hot water. The same thing that happened in the second experiment. About what? About the lightning stick.
Good. So hot water here. We know that from this previous experiment, we can have a large conclusion. What is the conclusion? Let's see.
The first thing we have the direction, which liberates the heat energy, the forward direction. This is the first part of the reaction. What about the second part?
The second part directly cooling shifts the equilibrium to exothermic direction to care for the factor of the cooling. What is the other one?
We have here the third part about this. We have heating shift the equilibrium reaction to the or equilibrium system to the endothermic reaction or endothermic direction. So here
you have a cooling shift to
the endothermic direction.
Exothermic for the cooling. Directly heating, it means?
It means the endothermic. We have the direction here, and the here shifts the equilibrium to the endothermic direction.
It's good to make a collision and comparison between the main two factors. What about the total one, the direction?
The direction which absorbs the heat energy, the backward direction. What's meant backward direction here?
Backward here, it means the reaction will back again to be shifted between the exothermic and endothermic. It's good to find the relation between forward direction, backward direction for heating, for cooling. Great and wonderful. Now,
we have the effect of pressure. It is a very important part of this lesson. Why? Because heat and the pressure, they are with each other, work with each other. Let's see the first thing about this.
About the effect of the pressure, it means you have a different factors. The factors here will back, as you see, the concentration of substance in the solution is given in the terms of molarity. Do you remember this word?
Yes.
What do you know about the molarity?
Molarity, it means what? It means the concentration of the substance in the solution. Which solution? It's 1 liter of solvent.
It's good to say that. It means depending on the volume. Now, expressed by placing the substance between the square brackets. Do you remember what is the square bracket about?
Yes, it's about the concentration of what? Of the substance in the reactant and the product in the equilibrium reaction.
It's good to say that, my dear. If the reactants or the products are in the gaseous state, the concentration is
expressed by using their partial pressure.
Partial pressure. It means we have a total one, yes, but we talk about gaseous state, so we catch the partial pressure. Let's see this example.
We have now the example here. N2, nitrogen gas, and we have 3 H2, 3 moles of hydrogen gas react to each other. So, by heat energy, give us what?
It will give us ammonia, 2 molecules of ammonia, 2 NH3 plus H. Oh, what's meant by the H here?
H here, it means 1 mole of hydrogen. It's equal what? Equal minus 92 kilojoule. It is about the exothermic reaction that liberate some amount of heat energy that equal what? Equal 92 kilojoule per mole.
How can you know this is exothermic? You know by the negative 92 kilojoule. Great and wonderful. My lovely students, you must know Kp. What is meant by Kp? It means
It means the constant equilibrium for pressure.
good. We say it's mean for the pressure. Directly we say P between brackets NH3 all power 2. What does this mean?
It means what? It means the pressure of the product here, NH3, ammonia gas. Power of 2, it means power of the number of moles that produced from this reaction.
Directly fly to the reactants. The reactants, it will be P N2 power 3 by pH2. Now, concentration of the products on concentration of reactants. Both of them give us what?
Give us the Kp. Kp, it means the constant equilibrium constant of pressure.
It's good to understand this. What about the first one? The power will back to
We'll back to the number of moles of the product here.
so must be written at the top of the bracket, not beside. Take care. Now you have another example.
This example about what? Calculate the equilibrium constant Kp of the reaction, the following reaction. N2 plus 2O2, it's 2 moles of oxygen with 1 mole of nitrogen. It's reversible reaction between them to form what?
To form directly 2NO2. But I want to ask, you have here 2 arrows in different directions. We said before, it means
It means reversible reaction.
it means reversible for the forward, backward, it can return. Now, what do you want from this example? The solution directly start with
Start with Kp.
stop. What is meant by Kp?
Kp, it means the constant of pressure or equilibrium constant of pressure.
This means we have a products and reactants. Directly you get as
P, between brackets we have NO2, power of 2, power of the number of moles that produced from this reaction.
it's good to say that. What about the product? The product here will be
Will be P, and we have between brackets N2 times what? Times P O2 between brackets and power of 2.
my lovely students, take care. This bracket not a squared one, it's normal bracket. So you must differentiate between Kp, constant equilibrium for the pressure, and Kc. There is big difference between the shape of the bracket. Now, my lovely students, what about the power means?
It means again the number of moles that produced from what? From the reaction of the reactant here. It means 2 moles of NO2 here.
Good. Now, my lovely students, power all time that we need. Fly to this solution. The solution here, Kp equal for the shape P power 2. Oh, 2 power 2. What this mean? It means the number of
Number of molecules.
for the products. It means NO2. Now divided by P point brackets 0.2 by 1 between brackets power 2. It's good to say that we make substitute between the symbols by the numbers. The answer for this case will be
Will be what? Will be 2 power of 2 divide 0.2 times 1 power 2 equal 20. And we have what? We have no. Here we have no measuring unit. Why?
because we have a ratio. During work through this ratio, you haven't unit as Kc, which you studied before. My dear, look at this. We can conclude that for the first,
Increasing the pressure or cooling on the gaseous state or gaseous substance,
this means
reaction at equilibrium shift the equilibrium in the direction of what?
direction of reducing the pressure, the direction in which the volume less or the number of the molecules is less. Why? To make a shift between forward direction and backward direction. So you can find that.
The decreasing the pressure or heating on the gaseous reaction at equilibrium. So here, shift the equilibrium in the direction of increasing pressure. What's meant by this?
This it means the pressure work in the direction which is a volume. A more or the number of the molecules is more to be shifted. Example to explain this shift. Stay.
Calculate the equilibrium constant of the pressure Kp of the reaction. Which reaction here? We have H2 plus 2O2. And what are the products here?
This is directly, we say, a reversible reaction. Directly, we have two molecules of the water, 2H2O. It's good and great. Now, what is the reactants here?
1 mole of hydrogen plus what? Plus 2 moles of oxygen gas.
So, we have a reversible. The product directly, it will be two molecules of the water, 2H2O. Solution. Directly, we have Kp, constant equilibrium for the pressure. The answer here will be
P, capital for pressure, and H2O, power of 2. The meaning of power of 2, again, we have 2 moles of water that produced from this reaction as the product. Over what?
over the reactants PH2 by PO2 power 2. It's good and great. Now, what is the answer after that? 2, it means the number of the molecules. We said it many times. Don't forget to put the power as you see. Fly now to the other part of solution. Kp
Equal 4 power of 2 divide what? Divide 0.3 between brackets. Don't forget the brackets. Times what? Times 1 power of 2. It's equal what? Equal.
Directly, we say we have a different powers. It means we have 50.3 has no unit because you work through the value. So the substitution between letter, symbols, or formula by the numbers. Now we catch Kp. My lovely students, this is not all. We have also Le Chatelier. Do you remember?
Le Chatelier principle. We talk about a theory of this scientist to make what? To discover or to illustrate the equilibrium system.
Let's see that. Le Chatelier, I like this man. It's a French scientist formulated a rule named after time.
Here we have 2 test tubes. One of them that contains a solution of cobalt chloride 4, it's blue color. And we have cobalt in water or dissolve in water, pink color. Plus what? Plus water.
This is, it means this it's a change between the cobalt for the blue directly to hydrated one. It change into cobalt hydration for the pink color. The difference between the two colors
from what? From the number, from the compound or from the pressure in each one of them.
From the blue color directly to pink. Look at this. When we lose this hydration again from the cobalt, directly return back again to the blue color. My question or time about Le Chatelier. What do you want? What do you mean? We mean to make
what? To make the equilibrium between these two test tubes in the same type of what? Of the compound. Here we have one of them is blue color because it has no water, and the other one that contains water, so it change its color. But Le Chatelier change the direction into what?
To make a shaft equilibrium to see what work through it. For both of them, you have aqueous solution. Aqueous, it means you have 6 molecules of the water for this reaction. Directly 4 molecules of Cl will be evolved. Also, it's an aqueous state. But the other molecules of the water, 6H2O, will be combined directly with the cobalt. Now, you see the shift here. Try to change from the blue color to
the red or pink color.
This is shift for this reaction. My lovely, these drops of the water evolved in the tube of what color?
Of blue color.
This it means try to return to make a shift between the two sides of reaction. Now, this is the important work for Le Chatelier. Do you think this is all? No, equation can be written as
Cobalt chloride 4. This is what? This is -2 in aqueous solution plus 6H2O in liquid state. Give us what? In the reversible reaction between them, we have cobalt H2O, 6 molecules of H2O, and in aqueous solution plus what? Plus 4Cl negative 1. So it is also in what? In the aqueous solution.
now you must know it's a reversible move in two directions. Now, what is the depending? Depending on the important factor. This factor, it means drops
Drops of water.
why
To be more equilibrium between them.
my lovely. When you get two beakers, one of them has hot water and the other cold water. Now I try to add the tube of the cobalt hydrated in both of them. For the first one, it's normal water. What happened?
The color of the hydrated water, it will be red or pink as it is.
Good, but this is not all. The molecules here start to work, but in slow reaction. It means the collision between the molecules start to work. Oh, we work through these molecules of the water? Yes. Do you think why?
Because the heat energy here, it's increase the spaces between the molecules of water and speed the collision between the molecules here. And we have the second one. If you put this one or these molecules of cobalt chloride in what? In the hot water like this, we will see the more reaction that happened here.
From the time to time, you can see the collision here, it changed the color of the tube. This it means the color will be changed from the the color will be changed from the pink to the blue. Now, ask all time, this is what happened. It means the shift between hydrated cobalt and normal one by losing the molecules of chlorine help for formation of this blue color. This is happening all in normal beaker. My dear, this rule predicted the effect of the different factors such as concentration. This is not all. We have also,
We have temperature and pressure.
this is not all. Temperature, pressure, concentration, all of them on the,
System at equilibrium.
it's good to say equilibrium because we need a shift. My lovely, look at this.
Le Chatelier principle. What does it mean?
This it means it's a state that a change in any condition. Do you remember what is the condition?
Yes, we have three conditions here. The temperature, we have pressure, and we have concentration of the reactant.
Good. All of them chemical reaction at equilibrium. This is the example. Concentration, pressure, temperature. Yes. What else?
It will shift the equilibrium system in the direction which oppose this change. So we have the change of pressure, it's in the opposite direction of this change, and the temperature also, the direction will oppose this change to the other direction.
Good. Now we have catalyst. It's wonderful to talk about this. As a beginning, catalyst, helper. This is help us to make a reaction faster, but all time has no change. This is not all. Look at this.
So the effect of the catalyst, we have seen that slow reaction produced at the faster rate by heating.
So proceed all time in the faster rate by heating. This is not all, but in industry, this very expensive result in increasing of this cost. How can I do that? How can you increasing the cost of the product? Is not important, is not easy for us. So we need to decrease. What we do after that?
Due to the additional cost of the fuel used for heating. So Here we have this experiment about. Here we have a sheet of copper and we have some kind of liquid that's called here. We have acetone and we have these two cups or two beakers. So here what will happen after that?
This acetone, it's a normal one. It's a dangerous acetone. It's a flammable materials and they give high temperature. It's difficult to use it. Now, I want to know what is the effect of this catalyst. Bring this a piece of the copper and give it this shape as you see. We use copper here. Why we use it as?
It's as a strip, or it's what? It is the colloid one, or it's the zigzagged one to increase the area or the surface area of this reaction.
Good. And we can say we use it as a catalyst. Yes, we have acetone to tell me what happened. When you get these tubes which contain the liquid of acetone and put it by this normal shape. Now, concentrate for the material, this important lab. The amount of the acetone is not higher, but we want to know if this increase or react or no. This reaction about the copper, piece of the copper and acetone stay as it is or increasing. This it means you have catalyst.
Catalyst it means what? The type of the substance, element or compound that used in the chemical reaction to speed the rate of chemical reaction or to speed or make the reaction more faster without what? Without any change of the same catalyst or the same what? The same substance that used as a catalyst.
Be careful, my lovely students. This reaction is dangerous. So we have the fire extinguisher as you saw it before, and all time we see, take care, close the bottle of the acetone well and make it away of the reaction because we didn't want to make explosion for these materials. Every part away. This is flammable, flame. Why? To make it away because we have a dangerous. What about if it's started to work now? What happened for this?
Here we have the reaction here. That's what? That's between the copper piece and what? And this one or this sheet. Put it inside the beaker of the acetone, and after some time we have what? We have the acetone is the flammable material that make the reaction between it and what? And the copper. How come?
The reaction here is not start yet. We have the copper, there is no reaction. Must be heated to be active for the reaction. Look, during heating, the shape of the color of the copper is changed. Now, put it in acetone and be careful. Look at down. Do you see what happened?
See here we have the heat energy increase in the copper here after burning this piece of this one, and we have the acetone increase the reaction between it and what? And the copper here. Why? Because the heat energy, it's what? It's the increase the collision between the molecules or collision between the particles of copper, and we have the acetone. It makes the increasing of this reaction.
Good. Look at this. When there is no light, the reaction is stay. It means the copper is a catalyst here. The reaction is stay although there is no heating. The amount of the light of the copper increase. Tell me, the catalyst is important. Do you think that?
Yes.
Is important for what? The reaction
will be more speed.
We arrived to the end. I hope you to understand the lesson well. See you and goodbye.
Dear students, I hope to enjoy your time with us. Till we meet again in another session about chemistry. Till we meet again, thank you and goodbye everybody.